Yeah, welcome to Azure Cosmos DB conference. And myself, Amresh, and I'm working as a solution architect at Maersk. And I love building complex cloud distributed systems. And I have with me today sessions Sonal, and she is my colleague. And we both are working in Maersk, where we are trying to migrate large scale distributed systems to cloud. And we have also got our handles displayed there. And if you want to reach out for any feedback, or if you have any questions, or you want to connect us later, please feel free to reach us in the Twitter handle and also in the LinkedIn handle that's posted out there. With that, let me get into the session. So today's session is more about Cosmos DB and how we have used Cosmos DB, especially with Mongo API. And before getting into the session, just want to set some context of the agenda. So first thing we will go with what Cosmos DB is, just to level set the audience. And then we will also see what Cosmos DB with Mongo API has to provide to us and what we have done in Maersk. And I also want to walk you through setting up of Cosmos DB with IAC tool, which is the Terraform. Want to walk you through the scripts and show how this is going to come and how can we set up a Cosmos DB in Azure with Mongo API with different options, right? And this focus of the session is also more towards performance monitoring and how can we performance tune. So one of the things that we have experienced with Cosmos DB with Mongo API is, a lot of bottlenecks have come with performance, and we wanted to especially share with the community what we have done as a team to measure the performance and how and what are some of the things that can be used to correct the same. So that's the context of the agenda. With that, let me get into the actual content, right? So Cosmos DB, yeah. So Cosmos DB is a horizontal partition and widely distributed multi-model database service in Azure. And when we say multi-model, it supports most of the popular APIs like MongoDB, Cassandra, and it also has variations of graph database, which is Gremlin, and it also called column and key value store and native core SQL API. Right. So one of the powerful feature of Cosmos DB is this popular API support that it has, which is like supporting MongoDB and Cassandra. So what it means for customers like us who is coming from very specific skill sets of Mongo or Cassandra, it becomes so easy to get into Azure Cosmos DB and start our workload from day one without much configurations that's required. And we have also got to know Cosmos DB is so powerful with some of the features which I can walk you through in the next few slides. And these features of Cosmos DB, which is the native features of Cosmos DB, which is coupled with APIs like MongoDB, is become so powerful for many of the teams like us who wants to explore distributed database in Azure. So with that, let me say what are some of the features that made us to choose Cosmos DB Mongo API. First and foremost fact, out of many other dependencies, one of the dependencies that we have is a skill set. So most of the team was familiar with Mongo API, so we wanted to use Cosmos DB, a distributed database, and also its features. So this became very handy for us when we want to explore Cosmos DB with Mongo API. And some of the other features which we have thought through will be so helpful for us when we made this decision is, of course, the scalability factor. Azure Cosmos DB is highly scalable from thousands to millions of requests per second. And when we say scalability, it is both from storage and throughput perspective, right? Like scalability may refer, for some of them it may refer to storage, and for some of the use cases it may refer throughput that we get from a distributed database. And in that aspect, Cosmos DB fits perfectly to our use case, where we could in a moment scale to all the thousands of requests that we get for our application. And it also got great availability, close to 5 nines of availability. And this SLA is specific, not just for read or write operation. It is throughout the operations that we do with database. The SLA and the low latency is met. And one of the feature and one of the common thing where Azure Cosmos DB is able to do is to manage the low latency, because it is available in many multiple geographical locations. If I'm not wrong, close to 60 geographical locations we have got Cosmos DB, and throughout all of these regions we could get the throughput or the latency or the SLA that's promised to us, right? And another catch feature of Cosmos DB is multi-mode deployment, right? So one of the factor that we all have as a cloud database you have to think through is how much of amount that we need to pay for the usage. And Cosmos DB provides 3 modes through which you can control the request units that can be provisioned, and how are we as a customer using these request units, right? So One of the mode is provision, in which if your workload is so standard throughout the day, you can go and provision your workload. Say I need say 400 or 4,000 request units, so you will be billed so for that, right, per hour, how much ever the request unit was consumed per that hour, right. There is an option called auto scale, where if your request is so spongy at some point of time, if your request is peaking and at some point of the day it's low, then there is an option called auto scale, in which without any configuration from the code or from the customer or from the SDK, it's just the settings that we need to put in the Cosmos DB, where automatically the Cosmos DB can manage scaling up from 400 or whatever the minimum RUs that we set to the maximum RUs that we put, right? And so that way, one of the way you can bring down the cost, right? And the latest addition to Cosmos DB, they also support serverless. And in serverless, I mean, of course, you pay for what you use, and it is much more cost efficient. And we have also used serverless, where we have to use for dev and test workload, where it is not as consistent as what we see in our prod. We have also put serverless, and that way, we manage the cost, and we also bring down the cost, right? What we do for Cosmos DB. And another nightmare for most of the DB admins out there is not the database upgrade itself, right? So in the past, we have all have experienced, right? Like whenever we have to do the database upgrade, of course, we have to plan it much ahead of time, so that we have to also let people who are using the database to watch out for some functionality which may break because of upgrades. But Cosmos DB again, on that aspect, is the upgrades just takes a second. I can also show you in the portal, where we just have to go to the portal, and you can just upgrade from the portal. And the best feature is, of course, it comes with zero downtime, right? Like if you are having active consumers connected to the Cosmos DB even during the upgrade, absolutely we have not faced any issues at all, right? So that's one of the powerful feature, I would say. And another strong point of Cosmos DB, of course, I guess one of the only cloud database, distributed database, that provides this option, which is called consistency options. Where when I say consistency, it's about how you manage the consistency, availability, and partitions of all the data that we have. And it provides well defined granular level of consistency modes to choose from: strong and eventually consistent, right? And of course, based on the workload and demand, you could choose. And again, it's a configuration that we need to put in the Cosmos DB, right? If you want, if your application demands across all the regions, if you want strong consistency, you could do so. But then there are, based on the applications, where if based on the workload, again, if you feel that if your reads and writes can eventually be consistent, you could do so. And there are well defined consistency options in between strong and the strong and eventual consistency mode, and you could also choose any of these options from the portal, right? So that is one of the option. And again comes the next important aspect of any database, is the backing up of the data, right? So we all have experience where we have lost the prod data at some point, right? And like we have also written some of the scripts or pipelines to kind of save the save the data into some form of the storage, right? And again, Cosmos DB is kind of provides that support as well through the portal itself, and of course through the configurations, like we can have continuous and periodic backup options. And also when we have to restore, say in case of any eventuality, if you want to go back and restore the database, we could do so from the portal itself, like point of time backups, right? So these are some of the features that is coupled. Of course, I've not talked about Mongo API is by default that's going to be supported by Cosmos DB. And apart from that, these features helped us made this decision that we should go for this API and give it try, right? So that's one of the key aspect of Cosmos DB and Mongo API features. And as I said, I also want you to walk through what we have done using Terraform, how we have set up Cosmos DB. And through this session, in the interest of time, what we have done is I'm just trying to show you the scripts what we have done to set up the Cosmos DB. But in Terraform, we have already run the script and set up this Cosmos DB as well. So the first is a resource group which we have created in Azure portal using our pipeline. And here you could see that in the Terraform, we just go and give what are the standard name and the key value pairs what's required for the configuration. And we have set up the Cosmos DB in West Europe region. And in Terraform, there is an option called capabilities, where it can take an option like Mongo, and some of the other options it could take is Cassandra, and Gremlin for graph database, and of course Mongo and table API. So we have used Mongo in this case because this is what we have tried. And I also talked about consistency policy, and you could do so. So we have tried session, which is a middle ground between the eventual and strong consistency. But based on the mode or the load, we can of course change it to any available consistency policy. So for the sample, we have just taken a database called food database. You can relate that this database is going to contain some list of products and its nutrition information. And we have created a products DB. And in this products DB, we have also got, what is the resource group name and account, what is that we need to set up. And it also got, throughput and auto scale settings. So I was also talking about, like what are the settings that we can define basically on the RU part. So this is what it is, like where we can say this is auto scale from 400 to 4000 is what we want to scale at the database level. And we also got a nutrition collection, which is going to basically contain all the documents or all the BSAN documents, what we call in MongoDB. And again, while creating the collection, there are options to specify which sharding key or partition key that has to be used. And similar settings, what we see in the DB, can also be applied at collection level, where we can auto scale from minimum to maximum RUs that we have defined. So that is also done. And we also got index keys which we want to create and manage in the nutrition collection. So in this case, we have put ID as a default index key, and we also created a product key, which is the partition or synthetic key, what we call it as an in Cosmos DB. And Sonal will walk you through what synthetic key is all about. And there is also constraint, which is called unique key constraints, that can also be placed on the collection while we create the collection itself. So of course, this is a script. And what we have done is we have went again and run against the script, and you could see this is a resource that got provisioned. And let me just go to the data explorer, and I could just show you what is the DB, what we have created through the scripts has been created. And what we do is, if we have to change any of these settings, we go and change Terraform scripts and rerun it again. So you get this database updated, right? So that is what we use the Terraform for. And also went ahead and created some of the documents which we will be using for the rest of the session. And I think this is from the demo perspective. And may I request Sonal to come online and walk us through the rest of the demo to show how we can change the measure and performance. Sonal, over to you.
Uh, yeah, thank you, Amresh, walking us through the Cosmos DB features and also giving a brief intro about how we use Terraform for our Cosmos DB setup. So, hello everyone. Now I'll be walking you through some performance aspects of the application. So, how what tools or technologies or whatever features that are available on Azure portal, what we utilize to measure the performance of our application. And after that, I'll also be briefing you about what measures did we take to make our application more performant and get rid of any performance bottleneck that we faced. So this first slide is about insights monitoring. So if you go under the database overview section, under this monitoring section here, you see there is the insights options available. Under this insights, there are so many tabs: throughput, request, storage, those are available, which you can go through and monitor your application based on storage or request or throughput perspective. But if you specifically come under the overview section, then you will find these four graphs here. And as you can see, we have a graph for total requests, which shows like how many requests your particular database has received in that particular duration. Also, another graph is about throttled requests. So there is a rate limit on the this Azure database, like how many requests can be processed in a time. So if the request goes, if the entire defined resources that you have defined for the database is consumed, and still there are more requests coming up, above the rate limiting defined, then your request will get throttled and you will get 4 to 9 errors. So this is a graph which shows, are there any 4 to 9 errors. Also, the another most important factor which measures the performance of any application from a Cosmos DB perspective is RU consumption. RU is request unit, and any operation that is performed on Cosmos DB is based consumes some or the some amount of RUs, and RUs on the backend are dependent on the CPU or memory or IOs for required for that operation to perform. So as and when the RUs increases, for example, in this graph, as you can see, this RUs are reaching to above around totally consuming the RUs to 100%. So definitely here it looks is a bottleneck, and we have to fix this to reduce the RUs, because if you the RUs consumption reaches 100%, then definitely you are about to get 4 to 9s, and then your application will start getting errors and the data will not be saved or searched. Next part of monitoring is under the monitoring section itself. There is this section called matrix. So matrix has a number of options, drop downs available, which you can analyze after selection the values from the drop down. So for example, this graph I have put up here is about normalized RU consumption, and then we can change the duration as well in which we want to see the graph. So for example, for this graph, as you can see, it was collected for 24 hours, and then you can see in this 24 hours the maximum the RU reached was 5%. So yeah, at this particular time where the application looks fine, so you can go here and see if RU consumption is reaching high, then yeah, that is a bottleneck. You might have to get rid of it and fix it. uh, Another graph that I have put up here is about server side latency. So this again is coming in the drop down options. So you have multiple drop down options which you can see. Whatever you want to use, you can search in those drop downs under this metric section. And server side latency just shows like what is the latency on the server side of while getting fetching the request or storing the DB. So as of now, this is pretty fast, so it's nothing to worry about, as you can see in the graph. Next section we talk about is metrics classics. So if you go under this metrics classics and under the storage section, you can see statistics about the partition key or shard key we call like what are the different shard keys or different partition keys available for your database or a collection. And then also you can see what is the data per index storage utilization for each of the shards. So and this shard key was to be, or partition keys to be visible on this section, it requires that the shard key is chosen wisely. I'll come to it later when we go into performance fixes section. But then the data should be uniformly distributed across all the shards. If the data is not of a good size, like here both the partitions have meat and vegetables have 1.38 MB of data, so it is a quite evident partition, and this will come in most of the hits. But if the data is not evident, I mean it's like 5 6 records in each partition, then you might not even be able to see the partitions here. So yeah, that's from the metrics monitoring perspective. So all those here on this portal we went through, and we just saw different graphs and try to analyze what needs to be fixed, and is our application performing well or it needs fixes. So this is how we monitored our application. Next, I'll go to what fixes we, or what performance measures we took to fix our application performance bottlenecks. So first thing that comes into picture is server version update. So probably when you create Mongo or this Cosmos DB version, there might be a possibility, like for us when we created for the first time, the version available was 3.6, but later on, as our application was still under dev, the version got upgraded to 4.2. So inside portal, under this features section, Cosmos itself provides us the facility to just click on this update Mongo server version, and then we get the option to just update the version without any downtime. And next one is server side retry. So as I've already told you that if there is a performance bottlenecks, our resource consumption is high, then in that case, while storing or reading the requests, our request might start failing, and we can start to see 429's error, that is the throttle request from Cosmos DB side. So if it's like for some particular time when your request just peaks and then it just falls back, so instead of so there is a possibility that what we can do is we can add a server side retry at Cosmos DB. So if you click on this server side retry here, this enable section will come up here. So what will happen whenever a 429 for a particular request will come, server will automatically try to retry that request one or couple of times with a short delay, and when it's successful, then fine, it will not immediately just go and fail the request on just hitting for the first time. So it allows us for a retry functionality, and that this is inbuilt with the Cosmos DB feature. Next thing we took care was auto scale. So they this under the in the portal overview section, I mean on the database settings, which Amresh has already told you that there we can set up a auto scale or database or a collection level. So for that settings, we can there is this throughput and auto scale, and then you can define like minimum is 400 RUs, and then you can define what to what max RUs your database or collection could scale. So this is as per the time when your application you are performance testing, you get to know, okay, for that particular maybe 400 RUs our data application is not able to take the load, then you can come here and increase and set the max RUs to higher value. So your database will scale up and down based on the usage on a particular day. And also also another thing that we did is, for example, when we are first creating a collection, there is some initial load that needs high initial load that needs to be injected in one go, and later on that will be there will be a nominal request to a collection. So then in that case, there we need a high RU while injecting that initial load. So at that time, we even bumped up the RUs to 20,000 just for that single write operation where all the initial data was loaded into the collection. And after that, we again scaled down the max RUs to 4,000. So this helps us, like if your if you have a data that needs to be injected in one particular day, if, it has a high volume and you need more RUs, then you can increase it to that higher RUs, and then maybe you can again lower it down depending upon what your application's requirement is. Uh, Next, as we have already discussed, that this scalability or auto scale can be added at both DB or collection level. So here, this on my slide, I'll be just giving a brief overview, like a brief comparison actually, what is the benefits of data, what database level auto scale does, and what collection level auto scale provides. So in case of database level, the elastically the database could scale elastically as per the defined throughput. And if the throughput is defined at the collection level, then each collection can scale elastically to that defined auto scale limit. Now, when we use database level throughput, now for example, for your collection, you cannot predict that what will be the usage of your collection, and then in that case, what you can do is you can define the throughput at a database level, so that all the collections that in part of that database can be the entire database can scale to that limit, and it will be not specific to a collection level because we actually don't know what could be the min and the max scale for the collection. Now, if you already know what will be the usage percentage of your particular collection, maybe minimum is 400 and maximum can definitely go to 4,000 for a single collection, then in that case, you can go and define the throughput at collection level. Another with the limit with the database level throughput is that when you define a auto scale at a database level, the maximum collections that a database could contain is only 25. But in case if you define the throughput at collection level, then there is no limit on the number of collections that you can add to this database. Also, in case of database level throughput definition, you don't have any guarantee on what will be the minimum number of RUs assigned to any collection, because it will be depending upon the load. So if one of the collection is the high usage, then the another collection which has very minimal usage might even drop down to very little RUs assigned. But if you have a throughput defined at the collection level, then that particular minimum RU will be dedicatedly available to the collection. So it's up to you what you want to decide upon. There is nothing like pros and cons on the level. It's just your decision, like which you want to, what database level or collection level throughput you want to choose. We on our application chose the database level throughput setup. Next slide is about sharding of collection. So I think Amresh already showed in the Terraform demo that food category was the shard key we use for our nutrition collection. So sharding of the collection is the feature of the Cosmos DB, which helps us to create multiple logical connections on one physical partition. And these logical partitions that we create, each of the partitions can scale up to 20 GB. So what happens is this sharding or helps us to wisely distribute the data. So for example, if you have an input request, and if you have and the request size or data size of your collection is quite huge, then the input request will traverse through all the requests to find what is the matching data for that collection. But if you know what could be your data in that collection could be segregated into which partitions, like food category maybe, then what will happen is as soon as your DB gets the request, then it can immediately know that okay, I have to hit for this particular partition, and then only the search will happen in that particular partition, and entire data will not be scanned. So it will be high performant. So but coming to the partition key needs to be chosen very wisely. It shouldn't be like it's leading to hot partitions. What hot partitions means, suppose I choose a key as food category and it has created two partitions, one with beef category and one with vegetable category, but my most of the input requests are only coming to the vegetable category, for example. So it means my beef category partition will be lying dormant and my vegetable partition will always be used. So then in this case it will be a hot partition scenario, and there will be not much benefit of creating partition, as my all the requests will always be redirected to one partition and not equally distributed. As I say, partition key should be wisely chosen. So this means like partition key should be chosen. You can keep a field as a partition key for whichever field is like is never changing. The value for that particular partition key should never be changing. So we can keep that field as a partition key. Also, that but if a particular field appears in all the collection, all the data of a collection, then you can choose that as a partition key. Yeah. These are the few things that you can keep in mind. And apart from that, if your particular field value is appearing on the where clause of your query, where food category is something, then yeah, definitely you can put that feed as a partition key. So you have to decide wisely what with partition key you have to provide for your collection. Next thing we used was synthetic keys or compound keys. So, for example, it's not always that we have a very large volume of data that we need to segregate into and have a partition key into our database. But still, the size is good enough that if we don't properly define the compound keys or define the to do not take proper measures, our system's performance could downgrade. So what we did was there is a concept of synthetic key. So for example, if your application is having multiple fields for a where clause, like 8 to 10 fields, then instead of putting passing a where on each of the 8 fields, what we can do is we can concatenate these 8 fields and keep one value. Like for example, here this product key in this image is the synthetic key, and it is a combination of food category and subcategory key. So now while inserting data, we have created this concatenated key, and while searching we'll not hit where food categories, vegetable and subcategories are exotic. We can simply come where product key is this. So this product key also, this synthetic key also improves the performance, and we don't even have to create a partition key if our data size is not that huge. Next, a well-known performance fix that comes into picture is indexes. So we have all the fields that are mostly coming into your where clause should be indexed. Otherwise, the performance could go bad from a DB perspective. So for example, here our application is using product key as a where clause. Then we have created an index on a product key. Next thing comes up is next feature that Cosmos provides is TTL index. TTL is time to live index. So, for example, you have a transactional data in your collection, or transaction data means that data is only valid for that particular transaction, or maybe after 3 4 days or 7 days, you are no need of that date particular data in your DB. So you can get rid of by setting a TTL index. So if I set up a TTL index for a collection as 7 days, then in that case, after 7 days, a particular record which was created 7 days earlier will automatically be deleted. And this will help us in just monitoring the size of the DB, that the size of the collection do not increase to a size where it becomes unmanaged. And although we were not even requiring the data to be there first thing in place, and we don't even have to worry about the archival policies and all those things. It's simply the data was already used, we don't need it, we can simply Cosmos will feature can take care of deleting it from our DB. Yeah, so these were the most of the features or performance fixes that we did on our application, and this helped us in fine tuning our application. Yeah, thank you everyone.